All right, so we're going to be talking about linear equations in this chapter 3. We get to talk about slope. We're going to visit a guy named Slope Dude. It's awesome. But for right now, we're just going to talk about being introduced to them. So first off, let's figure out what is a linear equation. So if you look at the beginning of the word linear equation, what word do you see? Yeah. So if you have a linear equation, that means you are going to get a line of some sort. So it's an equation that forms a line when graphed. If you have a linear equation and the line you get, or the graph you get is not a line, what does that tell you? What does that tell you? Well, no. If you're told it's a linear equation and you don't get a line when you graph it, what does that tell you? You did something wrong somewhere. Because remember, you need a minimum of 3 points to graph a line. Because if you just do 2, you'll always get a line. If you do 3, that's going to tell you if it's the right line or not. Because if you get a crook, that means something mathematically happened. Okay? So now we're going to talk about there's different ways to write equations of lines. And so the biggie is called standard form. Of a linear equation. And it looks like this. What's a comma for? Plus by equals c. Okay? So we have some rules about what that equation stands for. I think everybody understands what x and y are, right? Okay, there are coordinates of the points that are going to make that line. So let's talk about A, B, and C. So A, B, C, these are integers. Okay, notice, just integers. That means they could be positive or negative. Okay, but what it means is that it cannot be what 2 forms of numbers? Max? Yeah, no decimals or fractions. So no decimals or fractions. Okay. Now, in order for this to be still standard form, there's a couple other things. Now, some people argue about the next one, but it is the most common practice. Again, mathematicians, positive people, the first thing they don't want to look at is a negative. So for that, A is going to be greater than or equal to 0. And you're like, well, wait a second. How can I get a line if the A value equals 0? Because wouldn't that eliminate x? Can I get a line if I just have a y and a number? And the answer is yes. Anyone remember what kind of line you're going to get if you just have y equals 5? What would that graph look like? And don't tell me it's a line. It's a very special kind of line. Jack R., you look like you're thinking.
It's like a vertical line or something.
It's not.
Or is it a horizontal line?
It passes through the y-axis,
Yeah.
so it would be horizontal. Okay. So I know what's weird is because the y-axis is vertical, but you had to think, what is my line passing through? Which axis? Okay, so with y-only equations, it's going to pass through the y-axis and be horizontal to the x-axis. With x-only equations, then you're going to get a vertical line because it's got to pass through the x-axis, okay? So that is one thing. So in other words, we want a positive x, or we could eliminate x. That's okay. All right, and then the other thing I want you to note that may seem insignificant, but it is not, is that notice where x and y are. They are together on the left, in alpha order. So x always comes first. And the guy by himself, the c is the constant. Because remember, the definition at the very top, a, b, and c are all integers. Okay? All right, so let's talk about some things you can't have. Because one of the things, and this is probably one of the tougher things that we see in the quiz and test for this chapter, actually I think we only have a quest. This chapter's weird. At a certain point it changes direction of what it teaches, so we kind of take it and put it with chapter 4 a little bit because they relate to each other a little better. So there's a lot of that will happen for the next several chapters. Okay? For some reason, this is really hard. So in order to have an equation, we need to also have some certain criteria that we're going to follow. Let's see. Go here. So if I actually have an equation, these are things you cannot have. So equations cannot have a product of x and y. That won't give you a line, okay? So no products of variables. All right. You can have no exponents on the variables. That's not going to give you a line. And you can have no variables in the denominator, because that won't give you a line. Okay, so we're just, key thing we're looking for here is linear equations. So I'm going to draw a little linear equations. I want lines, so these are things I cannot have because it won't produce a line. Okay, so let's talk about graphing. So when graphing, two key elements to look for. One, you have your x-intercept. And that's going to be where the line intersects the x-axis. So an x-intercept is where the line intersects the x-axis. Now, what kind of ordered pair do all x-intercepts have? They all follow this same kind of pattern. Jenna?
X and 0.
Yeah. So the key here is the x value is going to come first. 0 is going to come last. Because when you have an x-intercept, the y value is still on par with the origin. It's still at 0. Okay, so now that we got that guy down, what are we going to say about y-intercept? What are we going to write that's going to replace where line intersects the x-axis when we talk about the y-intercept? F and M.
It would be 0 for x.
Oh, hold on, not there yet. The first part. So where I wrote where a line intersects.
Where the line intercepts the y-axis.
There you go. So where the line intersects the y-axis. Okay, and because I stole your thunder, how am I going to write my ordered pair?
So it would be 0 for x because it has to still be on the line,
Mm-hmm.
and then it would be y for could be any number.
Exactly. So with a y-intercept, it's just intersecting where the x value is on par with the origin. Jekka.
In the X and Y are together on the left,
Uh-huh.
you said that constants are alone on the left? Is that
Oh.
supposed to be right?
Thank you. I'll go back and correct that. I said the word, but I wrote the wrong thing. Isn't that funny? Constant alone on right. Isn't that nice? I can erase when I do it this way. Much easier. Okay, so what we're going to do is we're going to flip to the next page when you guys are ready, and we're going to work on the foldable page I gave you. All right, so to the next page. So this is something that will show up on the test, and for whatever reason, these kind of trip up kids. It says determine whether each equation is a linear equation, so write the equation in standard form. So we're going to write it in a standard form if it is a linear equation. If it's not a linear equation, then I can't write it in standard form. So there's two ways to do this. Go through your series of what I need to have or can't have. So I'm going to skip back to the other page. So x and y, no products of the variables, no exponents in the variables, no variables in the denominators. I'm going to check for all of those things. Or I could start by trying to write it as a in standard form and see how things go. So those are my two options. So I guess I'll do one each way so you see what I'm talking about. Okay, so first off, A, B, and C all have to be integers. Is that the case in number 1? No, right? I've got a fraction. Can I do anything mathematically to remove the fractions? And what would I be doing? So we're going to multiply both sides by that denominator. And we end up with y equals -3. So thinking about what does standard form mean, I'm going to write it over on the right side so we can think about that. So we have ax plus by equals c. Does this meet standard form? Is my a value greater than or equal to 0? Yeah, because if I have 0 for my a, 0 times x is 0, so I'm not going to see it. Are my variables on the left? Okay. Is my constant alone on the right? I have integers only. Yeah. So sometimes I have to do some math to see if it is actually in standard form. I have the ability. That's perfectly permissible for me to do. So the answer is yes. This is a linear equation. Oh, hello, if I could spell. Oh, my goodness. Okay. Now, this one would form what kind of line? And don't tell me straight.
A horizontal.
It's going to be a horizontal line because it's going to pass through the y-axis parallel to the x-axis. So this turns out to be a horizontal line because it takes the form of y equals some number. Okay? Awesome. All right, so number 2. Let's just go through what I can and can't have. Let's talk about what I can't have, because that's the best thing to look for. Do I have any products of variables? No. Do I have any exponents on variables? Yeah, I do. So that's going to be the big bugaboo is right here. So right then, because of that, that throws it out of being a linear equation. So I'm going to say no. This is not a linear equation. So therefore, I can't write it in standard form. And just a reminder, there's no exponents allowed. No exponents on variables. Could I have an exponent on the constant? Yeah, because I could do math to make that go away. Okay. All right. Next one. It wants us to find the x and y intercepts of the graph. The x and y intercepts. Now, I'm going to say the graph is a little hard to read, so I'm going to darken in my axes. I'm going to darken in my points. So, do we have a x-intercept that's easy to see? Yeah, it's pretty just standing out in our face. So, what's the x-intercept? Okay, now we're going to write it as an ordered pair. So what would the ordered pair be? 20 what? 20, 0. Okay. And then we have a y-intercept. And again, we're going to write it as an ordered pair. And what would it be? 0, 30. Okay, that wasn't so bad. All right, last one. Says the table shows a function relating the distance to an amusement park in miles and the time in hours the tourist family has driven. Find the x and y intercepts and describe what the intercepts mean in this situation. Am I going to have to do something to figure out the x-intercept and the y-intercept? Really? What am I going to have to do? Evan R.?
I think the x-intercept is the top one and the y-intercept is the bottom one.
Scratch that, reverse that. What's this one going to be? At the top?
The top one is going to be the y-intercept.
Right, because I have a value in the y-axis, and I have a 0 in the x. So this is going to be your y-intercept, and it's going to be 0, 248. So when you're seeing these vertical tables, the first column are your x values, and the second column is your y values. Now, we may call them something different. We may call the x h for time, and we may call the distance mi for miles, okay? So we can use the labels. Then, let's see, let's try this guy. This guy down here is going to be your y-intercept, right? I'm sorry, x-intercept. And he's at 40. So I didn't have to, do any fancy math to figure out the answer. I just had to look for the x's where we had a 0 in one of the columns and then figure out which one's which. Now, that only did part of it. The second part is to describe what they mean. So let's start with the x-intercept. So I'm going to do it over here. What does it mean when time is 4 and distance is 0? What does that mean in the situation that was given in this problem? Type.
They reached their destination, but it took 4 hours.
Okay, so this means the family reached their destination. After traveling for 4 hours. So that's an explanation of what that means, okay, for them to do what they're doing. All right, let's talk about the y-intercept. So that's going to be the 0, 248. What does that mean in this situation? Logan.
They haven't started the trip, and they need to drive for 248 miles.
Okay, so where are they right now? They're at home. They haven't left for their trip yet, okay? And it's telling us how far they'll have to go on the trip. So we could say something like, the family is at home, or still at home, and the amusement park they are heading to is 248 miles away. Okay? And that's that. Sorry about my little finger in the way. I always forget that's down there. All right, that's it for today, guys.